Okay, thank you everybody for joining us today, one of our special Contrail training series. We're going to be talking today about utilizing lightning and radar services in Contrail. We're really excited to be presenting this today in conjunction with Earth Networks. We'll give a little background about that here in just a second. So we're going to be focusing on how different ways we can use lightning coupled with Contrail and existing systems that we already have integrated in with Contrail. How can we use that together to get a complete hazard view of everything that's going on? So just a little housekeeping item here today. We're using GoToWebinar, so everyone should be in mute-only mode. So if you do have a question throughout the presentation, there is a chat button or ask a question that shows that should pop up a question dialog box there. And if you have any questions, feel free to ask that throughout the presentation. We'll have people monitoring those questions, so if we're able to work those questions in or work those answers in, we'll go ahead and do that. If not, we'll leave about 5 minutes towards the very end where people will allow people to unmute themselves and ask any questions, or we'll cover any of those follow-up questions that were asked throughout the presentation. Just a reminder, this will be recorded, so just keep that in mind at the very end as people unmute yourselves or ask questions throughout the presentation. So for introductions today, my name is Charles Jost. I'm the product manager of the Contrail suite here at OneRain. I'm also a formerly trained meteorologist, so this is an area that's of great interest to me, and really excited to present all the great work that Earth Networks and the Contrail developers have been working on over the last 12 months for this. And our co-presenter today is Steve from Earth Networks. I'm going to allow him to introduce himself in just a second. But Earth Networks is a sister company of OneRain. We'll discuss that in just a second here. And Steve there is a meteorologist and program manager for them. And he'll be discussing a lot of the lightning basics. He's got a couple great usage cases that we'll be talking about. And then at the very end, either myself or Mike Zukoski will be rotating back in to give an actual demonstration of what that looks like. So with that, I'll pass it over to Steve to do a more formal introduction and to get us started.
Charles, thank you so much, and welcome everyone on this very beautiful Wednesday as we're getting closer and closer to springtime and obviously thunderstorm season. So this is going to be a very relevant conversation as we talk about how to leverage the wonderful Contrail software platform utilizing Earth Networks' Total Lightning Network. And I think you'll find this very fascinating because, as Charles said, we'll dive into a couple of use case scenarios for you and explain how this software can be very beneficial to your organization, especially during convective storm season, which is, again, just around the corner, and in many parts of the country, especially the Deep South, it has already begun. So as Charles mentioned, I am a meteorologist as well. I'm also a program manager with Earth Networks. Proud to tell you I've been with this fine organization for over 10 years now, starting off as a meteorologist, working in the meteorological operations team, providing 24/7 coverage for clients like Major League Baseball, as well as many utility companies. But then I transitioned more into product management and then eventually program management for our federal customers, such as NOAA, NASA, and NIST. So I work with a lot of our federal clients to provide solutions to them that are helpful, whether it's lightning, greenhouse gases, weather data, access to our weather network and camera network. We are a company that has a large network of weather stations, lightning sensors, greenhouse gas sensors, as well as camera sensors and cameras all across the country and the world. So this is something that I'm proud to be a part of, and I love to share with you our technology. So without further delay, let's dive right into it. We have about 1,800 lightning sensors all around the world. And again, we are a sister company to our friends at OneRain. The lightning data has now been integrated within the Contrail platform, so you're able to leverage that. We are a global network as well, so we're not confined just to the CONUS here, continental United States. We have lightning sensors in Africa, Brazil, Canada, all around the world, and we're continuing to deploy more each and every day. It allows you to visualize lightning in real time. It allows also capabilities such as alerting for lightning, but also for other weather phenomena. We're going to get into that too a little bit later. There's access to historical lightning data. So maybe there was a terrible storm event that went through, your hydrological plant, and maybe you want to take a look back and see how much lightning actually was detected, when it was detected, and really dive into the details of that data. You're able to do that using the Contrail software. So it's very helpful, and I think you'll really enjoy what the capabilities are that we have in your hands. So let's take a step back and just talk about kind of Lightning 101, what it is, how it develops, how it forms. I think we're all pretty familiar with lightning season typically being during the warm months when the sun is out and heating the ground, and the sun obviously makes the ground warm. That warm air rises. As the warm air rises, you get updrafts. Updrafts are the storm's engine that you can think about. It fuels the storm. Now, it's not just warm air, but it's moisture within the air that can produce clouds. That's called condensation. So as that warm air rises, it cools to a level called the condensation level or the dew point, and you eventually see clouds start to develop, those puffy popcorn clouds. But eventually, those clouds can grow quite tall. Cumulonimbus clouds can be 40, 50, even 60,000 feet high. As that storm continues to grow, it gets to an area where it's below freezing. And this is critical for lightning formation, friends, because ice crystals will begin to form. They're the fuel for the thunderstorm and also for charge separation. So once we get ice forming in the storm, then that allows charges, positive and negative charge, to separate. And that becomes very critical because as those charges separate, we know from science class, the opposite charges attract, positives and negatives, negatives and positives. So there's a charge separation that develops within this cumulonimbus cloud. And eventually, once the charge separation becomes so strong, so great, the net result is going to be lightning. Different types of lightning, friends, to discuss. The first one is what gets all the headlines. It's called cloud to ground, or CG lightning. And there's a picture of it that you see there. Very luminous, very bright, very bold in that picture. Well, how exactly does a cloud to ground flash happen? Well, it actually is a very quick process, as we have seen, certainly with how quickly lightning can occur. But if you break it down, what happens is there's typically an area in the thunderstorm of negative charge, kind of in the mid part of the cloud. And there's an area near the ground that tends to have a lot of positive charge. Those tall, pointy objects, for instance, like trees, church steeples, utility lines, big buildings, they tend to accumulate a lot of positive charge. This is kind of a generalization. Not all the time will lightning strike the highest or the tallest object, but you've certainly heard that that is probably most common. So in this depiction, you see lightning striking trees or power lines, for instance, as an example. So what happens is there is an upward leader that's very faint. You probably don't even see it, and it happens in a fraction of a second. And that propagates upward from the trees or the tall buildings. Eventually, there's kind of a leader that comes down from that cloud. And once the upward leader meets that downward leader coming from the cloud, you get a return stroke. The return stroke is that luminous, bright bolt of lightning that you see that can do, unfortunately, damage and can be very fatal as well. So that's how it happens. It's both the combination of an upward leader, a little downward leader that's very faint, and once that channel connects, and it's all about where there can be the connection for that channel, there's a bright, luminous cloud-to-ground flash. About 10% of lightning is cloud to ground. So you scratch your head and say, okay, Steve, well, what's the other 90%? Glad you asked. We actually also have in-cloud lightning that we're going to discuss here in just a second. That accounts for about 90% of all the lightning. But let's take a look at what the approximate size is of a thunderstorm. Now, thunderstorms are generally small localized storms, as we all know. They range from, say, 2 to 6 miles. We'll say as an average, 4 miles in diameter. And the altitude might be about 4 miles as well of this particular storm. So let's think about this. Going back to science class, sound travels about 1 mile every 5 seconds. So light travels very quickly at the speed of light, much faster than sound. So you always will first see lightning and then hear the thunder later. It's kind of like if you're at a baseball game, friends, or even a fireworks display, and you might see the baseball player hit the ball, but maybe you're in deep, center field or in the nosebleed seats in the outfield. You might not hear that crack of the bat until a split second later. Or at a fireworks display, you see the big flash of light from the fireworks, but you don't hear the boom until a split second later, because again, sound travels much slower than light. So in our example, where we have about a 4 mile long channel of lightning there, it would take about 20 seconds for that flash to move through. So you'd hear the thunder rumbling for maybe 20 seconds as that whole channel of lightning propagates. So think about thunder as a sound wave that is the byproduct of lightning. Now we have different types of cloud to ground flashes. Most of the time, it's a negative cloud to ground flash. You say, okay, Steve, what's all this about polarity? Well, polarity is really the charge that is being lowered to the ground. So in the case of a negative cloud to ground flash, negative charge is being brought down to the ground. In the case of a positive cloud to ground flash, in this example, positive charge is being brought down to the ground. It's more rare. In fact, positive cloud to ground flashes are exceedingly rare, only about maybe 1 to 10% of the total cloud to ground flashes, but they can cause a lot of damage. Fires, structural damage, you're talking forest fires and power outages, and they also can produce something called continuing current. Continuing current indicates a lot of amps within that lightning that can lead to forest fires and initiation of wildfires. So certainly we saw that last year in the great western United States, where there was just an awful fire season given what they experienced last year. I also want to mention, very importantly, what a bolt from the blue is. It's a type of cloud to ground lightning bolt that comes out of a storm and can jump literally 10 to 15 miles outside of a storm. So it's called a bolt from the blue because, friends, you could be looking up and see a blue sky and sunshine, and yet you could still be struck, or your assets or your facility could be impacted by that, even though the storm is still 10 miles or greater away from your area. So a bolt from the blue is extraordinarily dangerous. And here's a depiction of what happens there. You see maybe in the upward part of the storm, there's an area of negative charge, which we talked about. That's often where the lightning channel will initiate. And instead of kind of going down to the ground, it kind of goes in a horizontal fashion first and then comes to the ground. So it puts it a great distance away from the parent thunderstorm. Again, bolts from the blue can dart out 10 to 15 miles from the parent storm. They're rare, but they happen and they pose quite a danger. Here's a great photo of such. You can see where the thunderstorm is located, and you can see that bolt from the blue darting out first horizontally, then cascading in a diagonal fashion toward the ground. And that can really do a lot of damage. You're talking about, trees and power lines can be impacted, forest fires as well from that. And also, it's why we recommend generally 10 to 15 miles as a radii for where you should have your protection ring set up for alerting. And we'll talk a little bit more about that here shortly. But finally, I mentioned intracloud lightning or IC lightning as the predominant lightning. It makes up about 90% really of all the lightning. And you say, okay, well, does it just stay in the cloud? Well, intracloud lightning could just stay in the cloud. But the point is, it doesn't strike the ground. It could be in the cloud, from the cloud to a point in the air, from a cloud to another cloud. The point is, intracloud lightning does not come in contact with the ground. But it is so important to realize intracloud lightning can be a precursor for severe weather, including flash flooding, large hail, damaging winds, and even tornadoes. That's why we recommend using the Contrail software package and visualizing total lightning. That includes both cloud to ground and in-cloud lightning. You get a full picture of where there's lightning and also if a storm is beginning to intensify. So take a look at this schematic here. You see the flash starting in the mid part of the cloud. You see that negative area where there's a lot of ice and charge separation. So it's an area of negative charge, and maybe it attracts a positive charge there. About 90% of lightning is intracloud, as I said. And it's obviously a hazard for the aviation industry, but you should also pay close attention to it because, again, intracloud lightning can still make thunder, and you can still usually see it, and it's important for DTAs. What are DTAs? Those are dangerous thunderstorm alerts. These are something exclusive from Earth networks that we supply to our friends at OneRain through the Contrail software package, where you can visualize alerts that are solely based upon lightning. There's no interaction from a forecaster or the National Weather Service. They simply provide you an advanced warning that there is a dangerous storm with a high flash rate that could produce hail, high winds, tornadoes, and again, flash flooding. So intracloud lightning is strongly correlated with the intensity of such storms. When you have a high flash rate, a high IC flash rate, again, it's usually a precursor for severe weather, and it provides increased warning over the National Weather Service. Friends, typically we've seen our dangerous thunderstorm alerts can come out 5 to almost 10 minutes in advance of the National Weather Service alerts. So it can provide you at your facilities, at your organization, advanced lead time to prepare, to get people to safety and shelter, to protect property, assets, and make sure that you are taking good care to secure property and lives. The total flash rate, which includes in-cloud and cloud to ground, is used to provide a significant lead time, as I mentioned. And again, these Earth Network's dangerous thunderstorm alerts only use data from the Earth Network's total lightning network, nothing else. They're 45-minute alerts. They're purple polygons, as you see in the picture there, and they simply tell you, hey, this storm is producing a prolific amount of lightning. Seek shelter. It very well could produce severe weather shortly. So what we do at Earth Networks is we define lightning cells. That's kind of a clustering of lightning, friends. We get a vector on that shows the speed and the direction. We then begin to track that storm and its flash rate very closely. We watch the flash rate, especially of the IC, jump. When that flash rate jumps or spikes up, we know that storm is likely intensifying. There's strong updrafts fueling the storm. There's likely the development of hail within the storm. Downbursts could happen. A lot of heavy rainfall that could cause flash flooding may be imminent. Possibly tornadoes as well as gusty winds. So all of those factors need to be considered. And you, with Contrail, are able to visualize this using our lightning cell polygons. I mentioned that DTAs, those are dangerous thunderstorm alerts that have a flash rate of over 25 in the wintertime and a flash rate of over 45 flashes per minute in the summer months. But there's also other polygons you can visualize, friends. Level 1 is a flash rate of about 2 to 3 or greater per minute. And then a level 2 polygon is over 12 flashes per minute. That's depicted in the green and orange respectively in that drawing on the right-hand side. So you can see very clearly that you can have multiple lightning cell polygons that you're visualizing and tracking. And it's extremely helpful as you move through convective season to provide alerting and advanced warning when there is bad weather coming. So we talked about the increased alerting times already. I just want to break it down for you from a study that was conducted looking at lead times for these severe weather phenomena, tornado, hail, and wind. EN is Earth Networks. That's the alert lead time. NWS stands for National Weather Service. So you look at the lead times provided by dangerous thunderstorm alerts versus the National Weather Service severe thunderstorm warnings, tornado warnings that they are wonderful in issuing. And you see that you can buy an additional 5 to 8 minutes from visualizing Earth networks lightning polygons like the DTAs. You can see that you get an advanced lead time, 28 minutes versus 20 minutes in a tornado, 27 minutes lead time from Earth networks in a hail event versus 20 minutes on average from the National Weather Service. And for a wind event like a downburst, microburst, derecho event, 26 minutes versus 21. So again, just an idea, this is a typical average that you do see an advanced lead time provided by our dangerous thunderstorm alerts. Still doing a little bit of lightning 101 when we talk about flashes versus pulses. This is important because when you visualize lightning from Earth networks within the Contrail platform, you're going to see the option for both pulses and flashes. So it's important to define what they are. A pulse is a surge of electric current in lightning that shows a burst of light, and they can be classified as either IC or cloud to ground. You can think of pulses almost as all those little tentacles that you see coming out from the lightning. And the flash is a collection of those pulses, the aggregation of them all in time and space that approximates the continuous ionized channel of a bolt of lightning. We give a special name to a CG pulse. That's a cloud to ground pulse, okay? So it touches the ground. We call that a stroke. And you can see in this example, in cloud lightning, as you see on the left-hand side, that stays in the cloud, and then a CG pulse that strikes the ground in that example there. Again, the flash is the entire current and includes all the little pulses that are included within the flash. You know, we here at Earth Networks also capture a lot of very refined and detailed information. It's something called lightning waveforms. So we can dive into waveform data from our sensors, and we can really see what a pulse is. Was it a cloud to ground pulse, or was it an in-cloud pulse? By looking at waveform data from our sensors, and just as an example, we have 13 sensors depicted here, and you see all those lines going across. This is a span of 10 seconds capturing data, and you see a lot of just these lines that are popping up. But here's what happens. When you zoom in, and we're now down to 2 seconds, we're now looking at a half of a second. As I continue this animation, we go down to a 1/10 of a second. You're zooming in on a particular lightning pulse. And watch what happens as we get down to a 50th of a second and then a 1,000th of a second. Aha, we're beginning to see a lot more valuable details on this lightning pulse. And eventually, look at that, friends, we're able to spot what is an Earth Network's total lightning network pulse. And you see it there. Usually there's a spike up as it's a cloud to ground, and then it comes down as it, of course, drops its charge into the ground. Very, very fascinating piece of information. But again, we capture all that data via Earth Networks here when we have our total lightning network. All these sensors are capturing the very valuable waveform data that help us distinguish between, you know, cloud to ground, which has a little bit of a different shape, versus in-cloud lightning that looks less of an amplitude. This is a little bit more dramatic and dynamic, and that's why we want to show you what that looks like, the cloud to ground pulse. So a flash is, again, a group of pulses. They're grouped together in time and space, as you see in the example there. Physics definition is it's a continuous channel of hot ionized gas. And you see 2 examples there of what flashes are so that we have a greater understanding before we dive into our use cases. And that's exactly what we're going to do now. We're going to take you through a couple of use cases from last year, 2020. First, I want to show you 2020 was an awful year for weather and climate disasters, friends. As you might remember, we had not only an awful fire season, the western wildfires were dramatic and gained a lot of headlines in the fall, but also our hurricane season. You look in the Gulf Coast and all those red hurricane symbols from Delta and Laura and Zeta, Sally, Isaias, Tropical Storm Eta. I mean, we went through the whole alphabet and then into the Greek alphabet. So a lot of storms, a lot of flooding, a lot of damage. These are billion-dollar weather and climate disasters, and it runs the full gamut. Wildfires, heat waves, severe weather events like a derecho, that's a strong straight-line windstorm, hailstorms, flooding, including a flooding event in Philadelphia I'm going to show you here shortly, as well as just severe weather events like tornado outbreaks. So many of these awful events occurred last year, and they were all billion-dollar weather disasters. So a couple of use case scenarios, actually 3 of them. First one is going to be showing you a COVID-19 vaccine testing site, or just another outdoor gathering space in which maybe tents are utilized, or inflatable structures that are particularly susceptible to high winds and dangerous storms. So that's one scenario. Another one might be if you're looking at a reanalysis of the data. You want to get archive lightning data from an event to see for forensics. When did that strike occur? Where did it occur? How strong was it? What was its polarity? What was its amplitude? You can find out all that information, again, leveraging the Contrail software through OneRain. And then finally, Charles is going to take us through a multi-hazard warning system, kind of show us a little bit about that, how together with hydrological monitoring systems, real-time weather and severe weather alerting are all part of a comprehensive package, a multi-hazard approach where you can improve your weather resiliency at your facility. So the first use case, everyone, is going to be from the Philadelphia area, where there were nasty storms just after the 4th of July, July 6th of 2020 last year. And boy, I have family in the Philadelphia area, and I remember them telling me about how awful this was. 6 inches of rain in just a couple of hours. Friends, to put it in perspective, that's about how much rain the Philadelphia area should get over 2 months, and they got it in 2 hours. So this was an unbelievable historic event. Frankfort Creek in that area had a flow rate that increased 35,000%. So an incredible amount of water being poured in. Obviously, it caused major issues. Flash flooding, water rescues were common. They were sending out people with lifeboats to try to get people to safety as soon as they could. That water rises so quickly, and as we know, all it takes is about 6 inches of fast-moving water can knock you off your feet. As we all know from going to the beach, 18 inches to 24 inches can float some cars. So it doesn't take much. And when that kind of water, 6 inches of it in 2 hours occurs, you have major problems. So take a look at this radar movie. It's from the National Weather Service. It's the Radar Mosaic, which is also available, of course, through the OneRain Contrail software package. And you see this mosaic from last July the 6th showing about 6 hours worth of radar imagery over the Philadelphia area. Storms are just moving over the same spot over and over again, kind of a training phenomenon we talk about. The yellows and the oranges and the reds indicate very intense storms, heavy rainfall that caused the flash flooding in and across the Philadelphia area. So let's say this was a COVID testing site, a vaccine site. You might want to set up, and we recommend 3 radii. So you might have your first one being an outer ring of about 25 miles, where once there's lightning detected within a 25-mile alert radius, there's an email warning sent to site coordinators to keep them aware there's a dangerous storm that's coming. It's still 25 miles away, but be prepared. Monitor the situation, follow the alerts from the National Weather Service, as well as those coming through the OneRain Contrail software. You want to stay on top of that situation. The second range ring is for 15 miles. That's when there's lightning that's been detected within 15 miles of that COVID vaccine site, and you need to make sure your key stakeholders are aware. You're sending texts and alerts to those stakeholders. They are monitoring conditions very actively, noting the direction, the movement, the speed of that storm, and they're prepared to secure the area. Remember, we talked about this COVID testing site, and it's got inflatable tents, so it needs to definitely be more secure, and you need to get people to safety and shelter swiftly. Within 10 miles, we have problems. That's when there can be lightning, cloud-to-ground lightning that can occur. So you're sending out those alerts, text alerts, mobile alerts to the emergency, public safety, contingency planners. You're planning to clear the area immediately, monitoring for hazards that could occur, hail, high winds, tornadoes, flash flooding. And also you might want to pull that lightning data from the event after the storm is cleared to just look at what happened and of course lessons learned. But we recommend these 3 rings, 25, 15 miles, and then within 10 miles to appropriately and safely monitor the lightning that's moving toward a COVID testing site. The second scenario, everyone, is going to be of the Midwest derecho from August 10th of 2020. This was a powerful, long-lived storm that moved across basically the entire Midwest, from Nebraska eastward to Indiana, even into Ohio, cost $7.5 billion in damage, the most costly thunderstorm event in U.S. history, nearly 500,000 total pulses detected by the Earth Network's Total Lightning Network over a 14-hour period, most of which you see were IC pulses, 390,000. Cloud to ground, over 100,000. Still very respectable, but the point is, this is why it's important to monitor total lightning in cloud and cloud to ground. Widespread power outages resulted from this, flash flooding events, and the storm, the derecho, that's a Spanish word for straight line winds. Well, this is a storm that races 60, 70 miles an hour. Take a look at this dramatic lightning movie. This is from the derecho last year on August the 10th. It's about a 12 to 14-hour movie of lightning. And what you're able to see with the yellows depicting cloud to ground, the purple in cloud lightning, there's a prolific amount of lightning with this event. Notice as it moves from Nebraska through Iowa into Illinois and eventually Indiana, it starts to bow forward like that. It has that arcing signature on it. That's an indication of very powerful straight line winds, perhaps some very heavy rainfall as well with this, and also a lot of lightning. Now, even though you can't see it all and recognize it all, there was a ton of in-cloud lightning. That's that purple magenta color that you're seeing there, but lots of in-cloud lightning and cloud to ground. It just happens that the cloud to ground lightning is depicted on the top here in this Midwest ratio example. So there you go, a couple of very dramatic examples and use cases of how you can utilize the lightning data for severe weather alerting, notification, information, and really situational awareness. And that's what we're all about here as we continue to move into convective and storm season. So to take us through the third example, I'm going to toss things over to our friend and colleague, Charles Yost, product manager and meteorologist. He's going to take us through this multi-hazard warning situation here. And Charles, I will let you take it away from here.
Okay, great. Thanks, Steve. And I'm going to go ahead and share my screen. Make myself the presenter here. And while I'm doing that, I do have a sick 2-year-old here. So if you hear any noises or squeaks or coming from my microphone, that's exactly what that is. And at that point, I might have to pass it over to Mike. So, but as Steve mentioned, we're going to be focusing on a multi-hazard warning. Now, Steve walked through great lightning basics and background about the different information that we can receive about lightning and deep convection storms. But we wanted to kind of tie it all back together, right? And this is really where Contrail coupled with the lightning data can provide the most value add. So when we think about impacts to our agencies that we support around the world, it's not just heavy rainfall and flooding. While the majority of the people on this call are looking at and using Contrail for heavy rainfall and monitoring flooding in real time and detecting impacts on the hydrology side, there's way more hazards that can occur and impact an agency, even around just the hydrology side. So here's kind of a pictorial diagram here that shows all of the different impacts that an agency could be impacted by. So obviously we'll start down at the bottom here with heavy rainfall and flooding and all of the impacts that are surrounding that particular hazard, right? So obviously we have flash flooding and having to evacuate people in low-lying areas and barricading cars and roads and things like that. But even within that same storm, we can have a number of other hazards that crop up, including lightning and severe thunderstorms, right? So tornadoes and hail and straight line winds that can produce hazardous conditions. And this is really critical, especially for the people on the call that are maybe coming at it from a hydrology perspective. Hey, when we're sending people out in the field to maybe respond to a motorist stuck in a roadway, or to go close a particular gate, or to go get a reading at a certain dam, we really have to be looking at all of these different hazards to make sure that we're both operating efficiently and within our standard operating procedure, but also that we're not putting unnecessary risks associated with these other convective hazards, including lightning and severe thunderstorms. And when we look at all of the different stakeholders, we just wanted to make a point of emphasis that while Contrail might be used in one part of a particular agency, with this data source and with all the different data feeds, combining all that information into one central spot to get that kind of single pane of glass view of everything that's going on, we're enabling all of the different stakeholders that might be impacted to utilize the data feed and Contrail to get that complete multi-hazard warning picture. And that includes everything from maybe you have 1 or 2 dams in your area that you're responsible for, and you have to safely operate those dams, or go out and monitor the structural integrity. Having additional data feeds about the severity of convective storms, including lightning, gives you that additional peace of mind when you're sending boots on the ground to maybe operate or make sure things are working correctly, that you're not sending them into harm's way. Or Parks and Rec, right? A lot of our agencies have additional departments that are doing Parks and Rec, and this can also help to combine all of those hazards into one view, right? So getting that flooding and rainfall view, but also everything around severe weather and convective outlooks. And as Steve mentioned, with those alerting radii and having multiple alerting mechanisms for lightning and for additional hazards, you can maintain that outdoor safety for both staffs and visitors, and obviously for emergency management, including forest fires and risk planning and high water rescues, as I mentioned before. So with this, we're gonna dig into Contrail. We're gonna do a demonstration of what that looks like in Contrail, and walk through maybe 1 or 2 alarming examples of how we can combine all that information into one view. And so with that, I'm going to exit out of the presentation here. And so here's a sample demonstration site that we've set up to look at this total lightning network that Steve has been discussing, and to show what that looks like integrated in with Contrail. So first, right off the bat, these would be additional layers and data sources that would be added to your existing Contrail package, right? So there's not an additional software page that you have to go to, or an additional service or software package you have to download or anything like that. It's all integrated into one software interface, and we're gonna be leveraging Contrail, because for all of the agencies on the call, they're already using Contrail for whatever their particular usage case is. So with that, I'm gonna walk through what it looks like and go over a dashboard example, and then 1 or 2 alarming examples to see how we can leverage that in real time. So first, I'm going to start off on the map first, which is the easiest way to visualize this information and to show it and combine it in with radar. So we're going to start here up in the Minnesota, Wisconsin area, where there is a large frontal system with some convection, at least on the leading edge here, where we're able to get some lightning. So we've lucked out with the lightning gods to get some real-time lightning data for our webinar. So here's what it would look like in Contrail. And in this case, we have an asset defined. That is this central site here, called it an example asset. But just as Steve was mentioning before, we have the concentric radii going around here that shows the different alarming criteria. I just have 2 for this particular example, but you can have as many as you would like, matching both either Earth Network's recommendations, or if you have your own specific criteria that you would like to be alarmed on. All this is configurable to meet whatever your agency's needs are. Okay, so we have 2 circles here. We have an outer warning circle here that because there's lightning activity within this circle, it has now turned yellow. It's an indication that whatever alarms or visualizations that you have tied, maybe you have, as Steve mentioned, maybe you have emails that get sent out to alert other agencies within or departments within your agency on what you need to do. And then there's a smaller warning circle here that is orange, and because there's lightning activity very close to our example asset, we can see that is now turned red. We also, this example asset, for those familiar with Contrail, is another sight and sensor in Contrail. So we're able to alarm on that, tie alarms and dashboard visualizations to that asset, and have that easily show up within the software. Okay, so this is the asset, and we're going to be talking a little bit about that going forward. And we can see, I'm going to toggle off the radar here so we can see it a little bit clearer. But as we look in the background, we can see all of the different flashes that are occurring across the area, right? So this is just kind of to the northeast here of Minneapolis, St. Paul area. And let's start maybe in the bottom left-hand corner so we can get our bearings on colors and shapes. So the first one in the bottom left here, we see in cloud. That is the arrows pointing to the left and the right. And then we have cloud to ground. So that is more of a lightning bolt with a positive and a negative charge here. And then down at the bottom, we have multiple colors. So red means that this lightning flash, in this case, occurred less than 5 minutes ago. And anything colored orange is less than 10 inches.
Mama.
Yeah. Okay, so with that, I'm going to have to pass it over to Mike here.
All right. Well, thanks, Charles and his son. I'm going to go ahead and show my screen and continue on this demonstration. So give me 1 second here. Okay, hopefully that's coming up for everybody now. Steve, can you see that? Because I can see you. Are you seeing my screen now?
Yes, I am. It sounds and looks good.
Great, thank you so much. I'm going to jump over to the map. And again, I just want to thank Charles for getting us started in this and working with his kiddo there. That's always a tough situation. And I also wanted to say, Steve, thank you for giving us that great information. I've been working with the lighting data for about a year now, but that was one of the best and most succinct summaries of the type of information that you guys are able to pull with your sensors and provide to us. So thank you very much for that. Really enjoyed that presentation. So I'm going to kind of get set up here similar to what Charles, where he was at. And again, I'm going to turn off the radar just to clean up our screen a little bit here. So just to summarize, down in the corner here, we have a color-based system based on the timing of the radar. You can see everything here is kind of red and orange and a little bit of yellow mixed in there. So it's out to about 15 minutes of data. So we have this color system. You may have noticed in Steve's presentation, some of the screen captures, the icons on the map looked a little bit different. We do have a number of options for displaying this data. So if you do already use Earth Network services in a different manner or using their application, we can kind of match that to show what you're used to with different opacities and things like that, which is helpful. We found with some different agencies we've worked with who are kind of used to one icon set versus the other. So we do have flexibility there for seeing it. I'm going to go ahead and just kind of walk through this menu to start. So right now we can see we have the CONUS defined here. So we're looking at the entire lower 48 of the US for the lighting services. We can bring this in and just have subsections that may be of more interest and more detail for your area of interest for your agency. But again, I'm just going to kind of walk through the menu. Just our standard map menus with opacities and legends and things like that will all be available to you. The first one here I wanted to point out is the flash versus pulse. So Steve did an excellent job there of describing the difference. If we just click on this, we'll probably see a lot more icons come out, maybe not a lot more, but as you learn a little bit more about the data, the pulses are very helpful for especially emergency operations situations. You get a little bit more of a broad view of everything that's happening versus the flashes, which kind of condense it down into smaller. It makes it a little bit easier to visualize over really large areas, but if you care about, you know, 1 or 2 or 3 assets, the pulses are probably more relevant for you. And stating with that, we do have the options for configuration. So these can all be configured. All of these options can be configured when you're setting up the map. So you can come in and see the pulses right away instead of having to toggle. We can, right now we have this configured for 1 minute, 5 minute, out to 60-minute data. So we can look at going back a decent amount. Right now it's up to an hour. And depending on your Contrail configuration and Contrail licensing, we can have that configured as well to meet your needs. So we can see it, we get a lot more data with the greens in here, so we see it back further. You can see there was a lot of in-cloud lightning here. So moving down the panel as well, as Steve was talking about, we have our in-cloud versus our cloud-to-ground lightning. So depending on your mission and your use case for leveraging this with the other data, we can visualize that lots of different ways. And then as Steve mentioned as well, again, depending on your Contrail instance, we're looking at current data here, but we do have the ability to do archival data. So we are collecting this data from Earth networks and storing it off in our servers, in our services that process this data. But what it allows us to do is go back in time. So, you know, I'll just jump quickly back to yesterday, hit the check mark. So as you can see, there was no lightning yesterday, kind of midday in the upper Midwest here. So this would be kind of our standard view when nothing is happening. But what it does allow you to do is go back and review history. So a usage case that I've talked with a few people who may even be on the call is, even if you have a RF network out there, you may want to set up an asset that is near some of your important repeater locations, for example, so you can determine if you're going to have network problems due to lightning, if there's lightning in areas when it went down. So very, very nice way to go back and visualize data and look back through the weekends or overnight and things like that. We do, again, have the ability for the proximity rings, which are these radiuses here, to have those on or off. That's just a customer request to just not clutter the map when they're looking at lots of different assets together. And it's just a way to visualize and change that visualization up. As Steve mentioned, they have some highly recommended radius. I think it's 10 miles and 15 out to 20. That is all configurable in Contrail just through our standard threshold tools. In this case, I think we've got it out to 35 miles out as a warning. Again, it's just kind of a demo, so we wanted to make sure people could see the colors changing and things like that. So, I think this is a pretty good visualization. One nice thing with this is we can combine it with other weather stations. So, of course, I'm looking at a really large view here with just a few sites across the United States. But point out just a few sites here. This one is where Earth Networks headquarters is. This is a weather observation site. So we're mixing the assets that we're keeping track of, which are up here in the Minnesota, Wisconsin area. We're mixing that together on the map with our standard weather observation data. In this case, it's coming from Earth Networks, which is, again, with our partnership with them, we can offer up their thousands and thousands of weather stations to supplement your data as well. So again, if you're looking at your network and want to add additional supplemental information, that is something we can help provide in addition to the assets. What this also indicates too is things you've seen with other components of Contrail. If I click on the site here, this asset, not only are we showing the proximity ring so we can show the lightning data around it, we're actually storing a lot of this data off. A lot of the sensors are not published, so we won't see them on the map. But we are keeping track of the number of counts, for example, over X number of minutes that we're seeing within our radius. We're keeping track of our pulse distance. We're keeping track of our currents. All of that relevant information that's provided through the Earth Network's total lightning feed. Through that network, we can store all of that data. And probably the biggest benefit to that is then we can combine that data with any of our other weather observation data so we can alarm off of it. So not only can you set up a standard alarm where you're looking at things like rainfall, those can now be combined with the lightning. So you can look for lightning that's coming, and perhaps you're looking for when rain is starting in conjunction with that. And we can have that set up to be for in cloud, cloud to ground, both. We have a lot of flexibility to combine all of this data with all of our other existing data. So again, it just kind of makes for additional powerful tools to help you complete your mission, especially around the emergency service space. As Charles mentioned, a lot of people on the call are involved in hydrology, but there's often a close tie between that group and other groups within your organization, out to people who are looking at keeping parks safe and keeping different areas of your city or county safe. And this data can all be used in conjunction with your existing hydrology data to pull it into one location to serve many needs, which is a really, really powerful component of having Contrail, which most of you have already, and bringing in all of these Great Earth Networks services. So the other thing I wanted to point out here, and then we'll kind of wrap it up so we can ask some questions, is not only does Earth Networks provide this lightning feed, they also provide a number of other data services. When we were looking at that radar there, you can see this is radar generated through Earth Network services, so we get a nice view. It looks a lot cleaner than, for example, some of the freely available radars that we can get through the National Weather Service and things like that. The other component that Steve talked a lot about, the dangerous thunderstorm alerts. We're continuing to integrate this in so we can do alarming off of that as well. I'm going to zoom out to the world here. Hopefully we'll see a few. I think there's one down.
There's one down in Brazil. If you can turn on that other lightning feed too.
Okay.
And then
yeah, sure. Thanks, Charles. So we have one dangerous thunderstorm alert here. We can see it's kind of sitting by itself because we're not showing radar down there, or excuse me, not radar, but lightning. So I'm going to turn on the lightning down there. We can see there is a pretty large set of a cell of lightning here. And again, we'd have to go back to Steve's presentation, but a lot changing, a lot of a lot of spikes in things in terms of currents and big jumps in numbers of lightning down there. You can see that cell is pretty active down there. So we can visualize all that now, and we're working on adding that into our standard alarming functionality as well. So really looking forward to that. That's going to be another great, powerful tool. They offer up a number of other layers. I'm going to go back to the US here for this one because it's relevant for people like Charles and I who live in Colorado. We're going to look at snow amounts in the next 24 hours. So lots of tools. I'm just bringing this one up because it's a pretty good graphic. We can see we're going to get a decent amount of snow overnight, and then we're looking towards the weekend at 2 to 3 feet, I believe, at least where we're at, of snow. So good for me for skiing, but maybe rough actually accessing slopes there. Charles, it sounds like you're back on. Is there any other comments you want to have here, or anything else that you would like to explain before we turn it over to questions?
No, I just wanted to, maybe Mike, you can click on dashboards in that first dashboard example, and just to kind of tie it back into that multi-hazard, as you're looking at, maybe you're sending someone out to open gates at a dam or to close barricades. Having these specific dashboards and lightning information allows you to understand all the hazards that person would potentially encounter. And with the combination of, as Mike showed, DTAs, being able to alarm on those DTAs and see what that time of arrival is, so you can have your folks out in the field be prepared for whatever hazard they might encounter, and to get that complete picture of not just what's the rainfall and flooding and hydrology impacts, but all of the impacts, as Mike and Steve both mentioned. We're not going to cover alarming, but you can see that we have a cutout here of a map widget that shows all of that same lightning information that Mike was showing, but then we can couple it with that sensor data, right? So maybe you have specific alarming criteria around wind and lightning, or real convective activity. You can have a dashboard here that has all the different widgets in addition to these lightning data feeds, including how far away your flash or pulse distance is and whether there's any alarms tied to it. So you can leverage the full Contrail alarm suite to meet whatever alarming criteria for everyone within your agency, not just within your group, but with the flexible user permissions and multiple clients within Contrail, we can have a complete alarming solution in addition to all the other sensors, as Mike said, for wind or rainfall or whatever your hazard outlook needs are. Contrail can combine all that information. So that is close to just about what we had prepared today. We do want to highlight one thing as we wrap up here. There are a couple of handouts here within the webinar, so feel free to check that out. We have a brochure about integrating Lightning with Contrail, as well as Earth Networks produced a really fantastic Lightning report that covers 2020. That includes some great numbers about different counties and states that have seen the most lightning activity, and you can start to get a sense of how prone your area is, especially as you're starting to enter this realm in this convective season. We did have one question that was in regards to recording. So we are recording this, and we'll be able, you'll automatically be sent a link. So if there's anyone else within your agency that might be interested in this, either in a different department or different group, feel free to pass that along, and you guys can start to leverage Contrail for Lightning data. So with that, feel free to type in some more questions. We're going to leave a couple minutes here, and we'll answer some questions.